Yes, this lecture video, we are going to study about second question A. Define a tautology. Prove that for any propositions P, Q, R, the compound proposition P conditional to Q, conjunction Q conditional to R, conditional to P conditional to R is tautology. Okay, so first here they are asking to define what is tautology. The tautology means the truth value will be true always. Look at here the definition. A compound proposition in which true for all possible, which is true for all possible truth values of its component is called tautology. So this you have to remember. Tautology means true. T for tautology, T for true. So that is true for all the truth values, all possible truth values. Okay. So that is the definition of tautology. Now let us see about the compound proposition what they have given. That is P conditional to Q conjunction with Q conditional to R. This is conditional to P conditional to R is a tautology. Okay, so that means this entire value we should get it as 111. True values we need to get. So for that here as you people see, this compound proposition contains the premises P, Q and R. So as I said, three propositions if we have, then we have to define 8 number of truth values, 8 possible truth values. So 4 times 0, 4 times 1. Then for second argument, for second proposition 2 0 2 1. Likewise 2 zeros 2 times 1. And for R, for this proposition alternating 0 1 0 1 we are supposed to carry. Okay. So now first you need to find what is P conditional to Q. Next you need to find what is Q conditional to R. Next you need to find what is P conditional to R. So for P conditional value, see for conditional, if you have 1 conditional to 0, then the value will be equal to 0. Otherwise, all the cases it will be 1 only. So look at the PDF here. P conditional to Q. So 0 conditional to 0, 0 conditional to 0, it is 1. Similarly, 0 conditional to 0, again it is 1. 0 conditional to 1 is 1 again. 0 conditional to 1, 1 again. 1 conditional to 0 is 0. Again 1 conditional to 0 is again 0. Next 1 conditional to 1, 1 conditional to 1 is 1 again. Likewise, we need to do even for Q conditional to R and P conditional to R. Just you need to look the propositions as relevant. Here Q and R should be considered. So where see here for these two, for 1 conditional to 0 we get it as 0. Again for these two, 1 conditional to 0 we get it as 0. So rest all the truth values will be 1. Similarly for P conditional to R, you need to look P and R. So here 1 conditional to 0, that value will be 0. Again these two, 1 conditional to 0 will be 0 again. Rest all the values will be 1 itself. So this is how the conditional this thing we are supposed to take. Next, if you observe the proposition, look at here. Next, we need to take P conditional to Q conjunction with Q conditional to R. And for conjunction, if I have 1 conjunction 1, then its value will be 1. If not, 0 for all the possible truth values. So look at here now, P conditional to Q and Q conditional to R we are supposed to take. So for 1 conditional to 1, it is 1. Similarly, conjunction. 1 conjunction 1 is 1, 1 conjunction 1 is 1, 1 conjunction 0 is 0. Similarly, 1 conjunction 1 is 1 and next 0 conjunction 1 is also 0, 0 conjunction 0 is 0, 1 conjunction 0 is 0 and finally 1 conjunction 1 is 1. So next finally conditional value again. Conditional to finally the entire thing we are going to take it now to show that whether it is tautology or not. So of course for this conditional we know that 1 conditional to 0 will be 1 conditional to 0 will be 0. Otherwise, for all other values, it will be true only. So if you look into this with conditional to this, see 1 conditional to 1 is 1, 1 conditional to 1 is 1, 0 conditional to 1 is 1, 1 conditional to 1 is also 1, 0 conditional to 1, 0 conditional to 0. All the values we get it as 1 only. So thus the given compound proposition is a tautology.